Let's work on this problem. Use the chain rule to find dz dt. How can we do this? Well, we need to use partial derivatives. So z is a function of x and y, as we can see here. And x is a function of t. X is equal to 4 plus t squared rather. And y is also a function of t. So to find dz dt, first we need to find the partial derivative of z with respect to x. So basically we're going in this branch of the tree diagram. And then we need to find dx dt. Notice that we're not looking for the partial derivative of x with respect to t, because x only has one variable, t. Z has two variables, x and y. So we have to take the partial derivative of z, but not for x. Now we need to take this branch to get to t. So we need to find the partial derivative of z with respect to y, and then dy dt. So now we can write the formula. dz dt is going to be the product of these two values. So that's the partial derivative of z with respect to x times dx dt plus the partial derivative of z with respect to y. So we're going in this branch, and then times dy dt. So that's the formula we need to use in order to get dz dt. So let's start with this. So the partial derivative of z with respect to x, we can call that z sub x if you want to. We're going to differentiate this function, but we're going to keep we're going to treat y as a constant and differentiate only x. So the derivative of x cubed is 3x squared. Y is a constant, so we're just going to rewrite it. The derivative of 3x squared, that's going to be 3 times 2x, so that's 6x. And y cubed, we're going to treat that as a constant, so we're just going to rewrite it. So now let's move on to the next one. Let's calculate the partial derivative of z with respect to y. So that's going to be z sub y. So we're going to treat x as a constant. So we're going to rewrite x cubed. And then we're going to take the derivative of y with respect to y. That's going to be 1. Keep that as a constant. So that's going to be 3x squared. And then differentiate y cubed. So that's going to be 3y squared. So this simplifies to x cubed plus 9x squared y squared. So now we need to determine dx dt and dy dt. So x is 4 plus t squared. dx dt, the derivative of x with respect to t, it's going to be 2t. Now y is 5t cubed. So dy dt is going to be 5 times the derivative of t cubed, which is 3t squared. And so 5 times 3, that's 15. So now we have everything that we need. So let's plug it into this formula. dz dt, that's going to be the partial derivative of z with respect to x. So that's everything that we see here. That's going to be 3x squared y plus 6x y cubed. Next, we're going to multiply that by dx dt, which is, here it is, 2t. So let's put this in brackets and then multiply this by 2t. Next, we have the partial derivative of z with respect to y, and that is this answer here. So that's x cubed plus 9x squared y squared. And then we have dy dt, which is 15t cubed. So I'm going to leave the answer in this form. But this is it. This is dz dt. So that's how we could use the chain rule to find it. Now let's move on to our next problem. We're given the functions z, x, and y, and we need to find the partial derivative of z with respect to s and the partial derivative of z with respect to t. Now, this problem is similar to the last problem, but the only difference is that in the last problem, x was a function of t only, but this time, x is a function of s and t, and y is a function of s and t as well. So we need a new tree diagram. So starting with z, we see that z is a function of x and y, and x is a function of s and t, and the same is true for y. So let's start by finding this particular partial derivative. Let's write the formula for it. So we need to focus on everywhere we see an s. So we're going to follow these particular branches. So it's going to be the partial derivative of z with respect to x times the partial derivative of x with respect to s. So let's write that. So the partial derivative of z with respect to s is going to be the partial derivative of z with respect to x times the partial derivative of x with respect to s. Now for the other side. So this is going to be the partial derivative of z with respect to y, and then we have the partial derivative of y with respect to s. So let's write that in the formula here. So that's the equation that we need to use in order to get the partial derivative of z with respect to s. So let's begin. So let's start with this one. The partial derivative of z with respect to x. So we're going to treat y as a constant. We're going to differentiate the x part. The derivative of x cubed is 3x squared. So we have 4 times 3. This is going to be 12x squared y to the 5th power. Now, let's find the next one. The derivative of x with respect to s. So we're using this. So t, we're going to treat that as a constant. So all we need to do is take the derivative of s squared, which is 2s. And so this is going to be 6st. Now, let's calculate the partial derivative of z with respect to y. So x cubed will be treated as a constant. So it's going to be 4x cubed times the derivative of y to the 5th, and that's 5y to the 4th power. So 4 times 5 is 20, giving us 20x cubed y to the 4th. So now we need to find the partial derivative of y with respect to s using this. So t squared will be held constant. So it's 2 times the derivative of s cubed, which is 3s squared, times t squared. So that's 6s squared t squared. So now let's plug in everything into this formula. So the partial derivative of z with respect to s is going to be this part, which is equal to 12x squared y to the 5th. And then that's going to be multiplied by the partial derivative of x with respect to s. So that's 6st. And then plus. So we have this right here. That's equal to 20x cubed y to the 4th. And finally, the partial derivative of y with respect to s, which is 6s squared t squared. So our answer is going to be 12 times 6, which is 72, x squared y to the 5th power, st, and then 20 times 6 is 120, and then x cubed y to the 4th, s squared, t squared. So this is our answer, the partial derivative of z with respect to s. Now, if you want to, you could replace x with 3s squared t, and you could replace y with 2s cubed t squared. So you can get the partial derivative of z with respect to s in terms of s and t if you want to eliminate x and y. But I'm not going to do that here because, as you can see, I am running out of space. Now, let's do the other part of this problem. So let's find the partial derivative of z with respect to t. And you could pause the video and try that problem yourself. So let's begin with the tree diagram. So z is a function of x and y. X is a function of s and t, and the same is true for y. So our focus is now on the t variable as opposed to the s variable. So we're going to take this path and this one here. So we need the partial derivative of z with respect to x and the partial derivative of x with respect to t. So we can say that the partial derivative of z with respect to t is going to be the partial derivative of z with respect to x times the partial derivative of x with respect to t. And then plus. Next is going to be the partial derivative of z with respect to y, and then the partial derivative of y with respect to t. And so that's going to be it. So now let's do the math. Let's start with the partial derivative of z with respect to x. So we did this already. It's going to be 4 times 3x squared y to the 5th. So that's 12 x squared y to the 5th. And the partial derivative of z with respect to y is going to be 4 x cubed times 5y to the 4th. And so that's 20 x cubed y to the 4th. Now this is going to be new. The partial derivative of of x rather, with respect to t. So we're using this, and s squared will be treated as a constant. So it's going to be 3s squared times the derivative of t, which is 1. So that's just 3s squared. And the partial derivative of y with respect to t is going to be 2s cubed, and then times the derivative of t squared, which is 2t. And so that's going to be 4s cubed t. Now let's put this all together. So the partial derivative of z with respect to t is going to be the partial derivative of z with respect to x. So that's 12 x squared y to the 5th power, and then times the partial derivative of x with respect to t. So that's times 3s squared, and then plus the partial derivative of z with respect to y. So that's 20 x cubed y to the 4th. And then the last one, the partial derivative of y with respect to t, that's going to be 4s cubed t. So the final answer is going to be 36 x squared y to the 5th times s squared plus 80 x cubed y to the 4th s cubed t. So that is the answer for this problem. For the sake of practice, let's work on one more example. So we're given the function of u, x, y, and z, and we want to find the partial derivative of u with respect to t. Go ahead and try that. So let's begin with a tree diagram. So u is dependent on three variables, x, y, and z. Now x also depends on three variables. It depends on r, s, and t. The same is true for y, and the same is true for z. Now, since we're looking for the partial derivative of u with respect to t, we're going to focus on the t variables. So let's start with this path, and let's write the formula. So the partial derivative of u with respect to t is going to be the partial derivative of u with respect to x times the partial derivative of x with respect to t. Now, let's take this path. So we're going to have the partial derivative of u with respect to y times the partial derivative of y with respect to t. And finally, for the last one, this is going to be the partial derivative of u with respect to z times the partial derivative of z with respect to t. So that's the formula that we need to use. Now let's get everything that we need. So let's begin by finding the partial derivative of u with respect to x. So y and z are going to be constant. The derivative of x squared is 2x times y. And notice that there's no x variables here. So that whole thing is a constant. The derivative of a constant is 0. Now let's find a partial derivative of of x with respect to t. So that's using this formula. So r and s squared are constants. The derivative of t is 1, so we just get rs squared. Now let's find the partial derivative of u with respect to y. So using this equation again, it's going to be the constant x squared times the derivative of y, which is 1, plus the derivative of y cubed, which is 3y squared, and then times z squared. Now let's go ahead and find the partial derivative of u with respect to z. So this doesn't have a z variable, that's going to be 0. And then it's going to be y cubed times the derivative of z squared, which is 2z. And so this is 2 times z times y cubed. Now let's find the partial derivative of y with respect to t. So using this formula, the r squared s part will stay the same. The derivative of t to the third is 3t squared. Now the partial derivative of z with respect to t is going to be rs times the derivative of t, which is 1. So at this point, we have everything that we need. I made one small mistake. Z is supposed to be rs t squared. So the derivative of t squared is 2t. So this should be 2rst. Everything else is okay. Now let's go ahead and put everything in. So the derivative, or the partial derivative of u with respect to t is going to be the partial derivative of u with respect to x. So that's this one first. So it's 2xy, and then times the partial derivative of x with respect to t times rs squared. And then it's going to be plus x squared plus 3y squared z squared. That's the partial derivative of u with respect to y, times the partial derivative of y with respect to t, which is 3r squared s t squared. And then it's going to be plus 2z y to the third times the partial derivative of z with respect to t, which is 2rst. So the final answer, all we could do is just multiply 2 by 2 to get 4. So we can write the answer like this. It's 2xy rs squared, and then plus. There's not much we can do here, so it's best to leave it the way it is. And then plus 4 zy to the third rst. So that's the final answer for this problem. So now you know how to find partial derivatives with the chain rule.